Hello my dear student, I am S Pandey. Today we are in lecture number 36. Lecture 36 of chapter 3, Current Electricity. Today lecture, my dear student, will start with an example. Ohm's law, combination of resistor series combination, parallel combination we have studied so far. So first question of today's lecture, you have to find equivalent resistance. Very simple, equivalent resistance. Here the battery, a conductor, simple conductor is connected, the 5 ohm, 5 ohm and 5 ohm. Suppose the 20 volt battery is being connected. Now my dear students, you have to find the equivalent resistance between these two. So try to see carefully and try to understand. My dear student, here the 5 ohm, you can see the 5 ohm and 5 ohm are connected. So the 10 ohm will be the equivalent resistance between these two since they are connected in series. But you can see this is connected with a conductor, so current will start flowing from the battery, of course, and the current will move across this conductor, but the current across this channel actually to this branch will be zero. Why? Because for this branch the two terminals are connected at the same potential and they will not receive any current. It means they have no any role in the circuit and can be taken out. So in this circuit now we will have only one resistance connected with the 20 volt of battery. And how much current will flow through this one? So the answer will be the current flow through this one is 20 by 5. Okay my dear students, but we have to find the equivalent resistance, and the answer of equivalent resistance, it is 5 ohm. Okay, that's it. The next question my dear students. Now I'm just modifying this particular question, the simple one resistor. Look at here, the same. Okay, let me just modify in this one only. If I connect here a resistance of 10 ohm, okay, then you have to find the equivalent resistance first, and then the total resistance, and then total current, and then current across each and voltage across each resistor, my dear student. Now the first one, the equivalent resistance. So the equivalent resistance is, these two are connected in series. What will be the resistance? The two are connected in series, so the equivalent resistance will be 5 plus 5, it is 10 ohm, and the circuit looks like this one. Here the 10 ohm and the 5 ohm connect the battery, that is the cell, 20 volt. Here the 5 ohm and this is the 10 ohm, and these two become the resistor of 10 ohm. Now this 10 and 10 will be how much? So this 10 and 10 will be 5, and this 5 already connected, so the R equivalent will be how much? 5 plus 5, it is 10 ohm. So the first answer, the total resistance is 10 ohm. Now the total current, so the I total, it is V by R total. Okay, and V is how much? It is 20 volt divided by the total resistance, how much? It is 10 ohm. So it was the 2 ampere current. From where this 2 ampere is flowing? So the 2 ampere is flowing from the battery. You can see this one. Now if the 2 ampere is flowing from here, so this resistor connected in series with this cell, and this resistor will collect the total current, because this cell has to again collect, according to conservation of charge and energy, the same current what that cell left. Okay, so this cell actually giving 2 ampere, so it will receive the 2 ampere, and the 2 ampere is coming from here. It means it is connected with the one resistor, so this resistor will receive 2 ampere. If 2 ampere current is moving from here, then what will be the voltage drop over here? So the voltage drop will be the 2 times 5, that is V equals to IR. IR, it is 2 times 5, it is 10 volt. You can see here the 10 volt drawn already. If in this circuit the 10 volt drawn here, then The rest circuit, you can see, my dear students, is this one. This one is the rest circuit, and this rest circuit will receive how much? So this receive the rest voltage, it is the 10 volt, because 10 volt dropped over here. Now you can see this circuit is like this one. This circuit, you can see over here, if the 10 volt is received by this one, here the 10 and 10 both are connected in parallel, so this will receive 10 and this will receive 10 volt. Both are in parallel, so in parallel the voltage must be same, so both will receive 10 and 10 volt. If it receives 10 volt, how much current flows through this one? So if it receives 10 volt, then the current will be 1 ampere, okay, and the 1 ampere goes through here. If 1 ampere is going through here and the 1 ampere is going through here, my dear student, so the 1 ampere is coming, 1 ampere is going, and the 2 ampere, you can see the 2 will be sum up and the 2 ampere goes to the battery. So in this way we have find the current and voltage across each resistor. Okay, now the next question, my dear student. Next question I'm giving you here for your classwork. You can see the example. I hope you will be able to solve this question. This is not very tough and neither it is very tricky question. Battery I'm connecting here. Look at the circuit carefully. Okay, now the values I am giving. The 5 ohm. This is also 5 ohm. I can wrap this one. 5, the 10 ohm. Here the 10 ohm, and here the let me take 150 volt. 150 volt. For simplicity, I'm giving you the very simple data. You can solve this question quickly. This is the positive terminal and negative terminal. Now, student, you have to find the equivalent resistance first, then the current across each resistor, total current of the circuit, voltage across each resistor. Okay, now pause your video and try to solve. Okay. Now, my dear student, I am solving. First, equivalent resistance. You can see, my dear student, if you are very intelligent, then you can solve this question. But I am helping those students who are not able to see the circuit in simple way. You can see this resistor can be taken above. Okay, it's no problem. If you will hold this resistor, this is flexible wire, hold this resistor to keep up in this way. The two resistors were connected. Okay, I'm solving this one. And here, one and the battery. And this one can be pulled up. But one resistor, yes. Now, this was the 10. Here the 150, sorry, the 5. This was the 5. This is the 150 volt. Here the 10, and this 10 goes up. So this one. Now I think this is very simple for you. You can solve now this question, but I'm helping you to find the answer. Look at here. These two are in series and then in parallel with this 10 ohm. So in series, if these two are in series, 5 plus 5, it will 10, 10 plus 10 and 10. In parallel, it will be the 10 times 10 by 20. It is 5, and this 10 is connected in series. Okay, like this one. This 10 and 10 become 5. And another, it is connected here, the 10, and then we are having a battery. This total become how much? This total become how much? It is 10, 10, 10, 5, and this is 10, 150 volt. Now the total resistance, you can see the total resistance is 10 plus 5. It is the R equivalent 15 ohm. Now B, if you is to find out the total current, it is the total voltage by total resistance. How much? 15, that is the 10 ampere. Am I right? Yes, 10 ampere. So the 10 ampere is drawn from the battery, 10 ampere from here. Okay, how much current will receive by this 10 ohm. Answer is 10 ampere. How much voltage will drop over here? So the 10 times 10, 100 volt will drop here. So the raised voltage, how much? 50 volt will drop across this branch. And across this branch, you can say if these 2 points, if you study the 2 points, this and this, and the 50 volt across this one, it means the 50 volt received by this branch and 50 volt received by this branch. Okay, so the 50 volt, it means the current will be here. How much? It is 5 ampere. And how much? Here the 5 ampere. In this way, you can find out the potential over here, the 50 volt, potential over here, the 50 volt, and the potential over this resistor will be how much? It is the 5 times 5 is the 25 volt and 25 volts. So in this way, you can solve. Actually, my dear students, I have given you a very simple question here, okay, to solve. Now, the next one. Let me run this one. The next question, another simple question. Okay. This is also your classwork. Okay. A battery I'm connecting. Now I'm just designing with the resistance. Suppose here the 10, okay, 10, okay, 20, suppose it is 3, 6, 3, okay, 3, okay, and 24 volt. This is the battery, plus minus. After a few classes, students, we will connect capacitor also. In DC circuit, we will study the R and C, that is the capacitor and resistor. Okay, so my dear student, you have to find the same, the 4 things: total resistance, total current across each resistor, voltage across each resistor. Now you can see this particular circuit is very simple, and this circuit, actually, to find the equivalent resistance, you can see these 2 are connected in series. So this will be here the 20, and then here the battery, and 1 resistor over here, and it is how much? So it is also here the 6, and it is 3. Okay, now if it is 20 and 20, then circuit looks like this one. Here the 20 become 10, the battery, and the 1 resistor over here. Here the 6 and 3 become 2. How? So 6 into 3 divided by 6 plus 3, it is 2, and here it is 20, 10, 2, 20 are in parallel, so it will be 10, and the battery 24 volt. How much it is? 10 plus 2, 12. So the first answer, R equivalent is 12 ohm. Okay, R equivalent is 12 ohm. Now the second one, the total current, I total will be the total voltage of the circuit. It is 24 by the total resistance, it is 12. So the 2 ampere. Remember, 2 ampere is moving from here, and here the same current 2 ampere will reach. It means, and here if it is 20, this is also 20, it means 1 ampere and 1 ampere equally current will divide. So the 2 ampere reach here the 3 and 3, 6, and here 3, remember. But you can see there are a number of ways to solve this question. Here it is the 3 ohm and here is the 6 ohm. We know that V is equals to IR. Okay, it is quite obvious the voltage across this one and voltage across this one will be same. So at constant voltage, you can write here the I inversely proportional to R. Am I right? So greater the resistance, the smaller will be the current. if resistance become double, the current become half. Here the resistance is doubled of this one, so the current will be half. Okay, 1 ampere is going through here. How much? 1 ampere is going through here, and this 1 ampere has to divide in 2 parts. But if it is X, then it should be 2X. Then what will be the amount of current across this and this one? I think you should solve now. Okay, my dear student. Okay, the next question. This other question, the way of question I have given you, I think we should not just waste our time. I'm giving you here the few homework, and then after we will move for the next few important and interesting question, my dear student. Okay, this is the homework. You know the resistance, the two resistor, let me make few more resistor, and here the stop. The circuit starts from here and stops here. Remember, it is not going to infinity. This all are equal 6, but this one is 4. Okay, this is also 4, this is also 4, and these are okay, 2, 2, 2, 2, here the 2, 2 and 2. I think all the rest we have taken. Okay, the 2 and this one is also 2. Now the question, I hope is very clear. You can see, if battery is connected at X and Y, okay, and these are the free points. These are the free points. Battery is connected between X and Y. You have to find current across each resistor. You have to find current across each resistor. If 1 ampere of current flowing through this resistor, if 1 ampere reached to this point, remember how much? 1 ampere. If 1 ampere, due to battery over here, here the battery is connected between these 2 points, due to battery connected over here, if 1 ampere reached to this point, then you have to find the current across each resistor, and also you have to find the value of V, the voltage of the battery, and the current across each resistor. Okay, this is very, very important question, my dear student. Okay, now next we'll move to the another question. I hope this question is very clear. This is not the infinite ladder. Here the limited resistors are connected. These two are free points. It is not connected anywhere in the circuit, but the 4 ohm and the 6 and 6 ohm, 2 are there, 2 are there. You have to find, if 1 ampere current reached at this point, then you have to find the battery, how much potential has been given at this point between X and Y, and also you have to find the current across each resistor here connected. This is the question. Okay, now another homework I'm giving you. What will be the, I think as I'm writing the question, you can solve this question. It will not take too much time, as the question, this type of question we have practice in capacitor also. What will be the equivalent resistance between X and Y? Hurry up. This is your homework. Okay, now another homework. Okay, I'll give you homework after few question. Okay, I'm writing the homework over here by pausing the video, so it will not kill our time, student. This is your homework. my dear student. 1, 2, 3, 4 and 5. Now I'm giving you the values of resistance. Okay, now the values are here. The this is suppose the one more resistor. If you will connect, then circuit will be little easier. So all the resistors are R. Okay, the R and R. I hope you are able to see clearly. Here this is 2R. Here the 2R. Suppose this is 4R. I am speaking also. I hope you will be able to write. Here the 3R. Suppose this is 2R. All are connected. Okay, then you have to find the equivalent resistance between X and Y. Okay, now this one R. You have to find equivalent resistance between X and Y. Now this one, it is 2R. It is also 2R. Here this is 2R. Okay, suppose it is R. This is also R. This is R, and this is also R. You have to find the equivalent resistance between X and Y. My dear students, listen carefully. This is very important. Actually, this conductor from here, it is going with the resistor, and then it is not connected with this conductor. Okay, this conductor is not connecting, not touched with this conductor. It is using a knob. It has been goes from above. Okay, it is not touching this conductor. So the resistance 2R, R and R. You have to find equivalent resistance between X and Y. Now this question. In this question I'm giving you R, 2R. Is the 2R. This is also 2R. Again, you have to find the equivalent resistance between X and Y. Okay. Now the fifth question here. Suppose this is R. This is R. 2R. Okay. This is R. This is R. And all these values are. This is also R. And all this one is 2R. Okay. So this is 2R, and 2R. Because the space is very small, I'm not writing, I'm telling you all these values are 2R except this one. This is R. Okay. You have to find equivalent between this X and Y. You have to find the equivalent resistance, my dear student. Okay. Now another type of question we will discuss today. Let me wrap this one. Now student, if this is a conductor, one example I am discussing. If this is a conductor of length L and resistance R. Okay. If I fold this conductor to make a circle like this one, what will be the resistance between, if this conductor has the resistance R, length L, and I fold this conductor to make the circle, what will be the resistance between 2 points which are diametrically opposite? Okay, what will be the equivalent resistance between the 2 points which are diametrically opposite? Could you solve this question? Pause the video and try to solve. Okay, now look at it for the answer. As you will make circle this conductor, the half of the length will be above and the half of length will be down. As you know, the resistance directly proportional to the length. If this length is half, then resistance will be also half, and this is also half. R by 2. Now these two resistors, suppose this is the resistor and this is the resistor. Now these two resistors are connected in what manner? These are connected in parallel. So the two resistors are connected in parallel. Very easy. The R equivalent will be R by 2 divided by the two resistors are connected. So the answer is R by 4. I hope you will get it. You will understand. Now, on the basis of this question, I'm giving you a homework. This is your homework. Okay. If the same wire of length L and resistance R is folded in this way, okay, and with the center, the 2 point we picked, which is at 30 degree. The 2 point we picked X and Y, which is at 30 degree. Okay. Then what will be the resistance between X and Y? R between X, Y will be what? And the next homework, this is the homework from here. Actually, the 5 or 6 question was there. Suppose for this section, it is homework 1 and 2. Now, if the same wire is being folded in a square, then what will be the equivalent resistance between two adjacent corners? If it is X and Y, then what will be the resistance? Again, remember, the total resistance is R. Here the total resistance is R. But what will be the resistance between these two corners? Okay, this is your question. Now, another type of question we will discuss today. This electricity and electrostat are the very important chapters. That's why we took number of lectures in this units. Okay, in these units. Now, my dear students, the one question here. Suppose another resistor. Here the two resistor, the one resistor have been connected from above. Okay. Okay, another resistor I am connecting from here. Now the circuit is being completed. This is the point X and Y. Suppose it is 6. This is 2, 1. Here, suppose 6. It is 8. It is 4. And this is also 4. Okay, student. Now the question: if 1 ampere current let me take, if 1 ampere between 1 and 2 ohm, suppose 1 ampere is current flowing from here. Okay, how? Due to battery 1 ampere. If 1 ampere of current flowing from here, okay, then find voltage between X and Y. Then find the potential of the battery which is connected over here. Pause the video and try to solve this question, my dear student. Okay, try to solve by yourself after I will solve this question. This is a very interesting question, my dear students. Now, step by step I'm solving. Try to focus over here. If 1 ampere flowing over here, if 1 ampere current flowing through this branch, what will be the voltage drop? Here the voltage drop will be 2 plus 1, because these two are connected in series. The resistance will be 3 ohm and the voltage drop over here will be 3 times 1, that is the 3 volt. If the voltage between these 2 points is 3 volt, how much? 3 volt. Okay, let's say A and B, this 2 point. If VAB is 3 volt, then what will be the potential across this 6 ohm here, if it is also the resistor having the 2 terminals, same A and B, so it will have 3 volt again. What will be the current across this one? if we are having the potential, how much? 3 volt. And if we are having the resistance, then we can find the current. Suppose this is I1. Okay, so what will be the value of I1? It is V by R, and V is 3 and R is 6. It means 0.5 ampere. Okay, 1 by 2 ampere. So the 1 by 2 ampere is moving here and the 1 ampere is moving here. How much current given by this one? Because half ampere goes to this direction and 1 ampere goes to this direction, it means the total current was given by this resistor as 1.5, that is 3 by 2. Okay, suppose this is current I2. So the I2 must be how much? It is half plus 1, 3 by 2. If 3 by 2 current, 3 by 2 ampere current given by this one, how much voltage will drop across here? So the voltage across this one will be, suppose this point as C. So the voltage across this AC or the CA will be V is equals to IR. I is I2, that is 3 by 2, and R is 6. It means it is 9 volt. Okay, I hope you are getting, my dear student. So between this point C and B, the total potential will be how much? Here the potential was 3 volt and here the 9 volt. So the total potential across these 2 points, it is, that is CB, VCB, it is 9 plus 3. Okay, that is 12 volt. I hope very easily we are solving and you are getting. Now look at here, this resistor having the 2 terminals between C and B. So what will be the current here? If the resistor is 8 ohm, okay, say it is I3. So I3 will be V by R. So V across this resistor, the terminals are C and B. So the VCB divided by resistance, how much it is? 8. So the current will be 12 by 8. How much it is? So it is 3 by 2. Again 3 by 2, that is the half ampere. Now if half ampere goes to this one and I2, it was 1.5, it means the total current move from here, say it is I4. Okay, what will be I4? So I4 is 1.5, that is 3 by 2, plus I3 is how much? It is half. So the total current, it is 4 by 2, it is 2 ampere. So the total current given by, okay, the total current given by this particular network, that is I4, is 2 ampere. If here the battery is connected, suppose a battery is connected between these 2 terminals and the current is given by this cell is how much? It is 2 ampere. Then how much current it will receive? 2 ampere again. And if it is 2 ampere, then the potential across here and here will be how much? So the 8 volt over here, because the 2 ampere will drop down here, the 8 volt, and here 8 volt. And what was the potential over here? The total potential, that is between the point C and B, so it was 12 volt. Now the total potential, that is potential of this cell, will be the total potential. It is dropped here, over here and here. So 8 plus 8 plus, it is over here how much? 12. So this is the voltage. Okay, my dear student, in last few videos, due to sleeping, just pen slip, you can say, the missing the writing, I have written few wrong derivation, so you can get correction by yourself. I hope you are much aware. Okay, now the calculations is this one, my dear student. we have running out with the time. Next class I'll give you few more questions to solve on the basis of this one. Okay, my dear students. So this is all about today's lecture. Thank you, my dear students.